Hello everybody, my name is Radosław and I want to just present my single double linked list. So the list attributes are data, next pointer, and pointer to the previous node. And that's the node, which is built from data, next pointer to the next node, and pointer to the previous node. Here is the constructors for the pointer, basic setters and getters, my iterator class, which is also template. You have only node which is type def, to don't have to write down all the time all that tail is that data type, and just pointer to the node. Also simple iterators and setter for node, getter for node, fourth function which just go to the next node in the list. If it's firstly check if it's valid, same with the back, which is go to the previous node in the list. Also first check if it's valid, which function we can see here. Data type just return data on that position. Here are more setters and getters for nodes and print node. That just prints pointers, addresses of the node and of the pointers to the next and previous node. My double linked list class which have head, tail and count. Here are constructors, destructor, function to check if the linked list isn't already empty, or yet is it empty yet. Here is function to insert first node or node on the beginning of the list. If it's empty, it's just create first node. If it's not empty, it's insert the node on the beginning of the list. Here we also can create a new node if the list is empty. If not, we just pass the node to the end of the list and put it there. That function just remove the first node. Here is function to remove last node, and of course all functions have set the pointers to the nodes to don't lose the track or mess with the list. Here is function to insert on the position. So we pass the position, we pass the data. Firstly we check if it's empty. If the list is empty, we just straight away create a new node and insert the data. Of course we increase the count. If not, we check if the position which is passed is less than 0. I allow to have number less or equal 0, and then if that's true, it's insert as a first node. If the position is greater than count or equal to count, I assume that user want to have that on the last as a last item in the list. If the number is between the 0 and the count of the list, so the size of the list, number elements in the list, we just go through the list using iterator. As long as it's valid, we check if the count is equal to the position. If it is, we create temporary node, store data in that node, Then we set previous node connection pointer to that temporary node. Then we move twice back to get to the node before the new one we create in that moment, and we set the pointer from the previous node to that new created node, and we increase the count. Here is the remove function, which works similar to the insert on the position. We just pass the position, check if it's equal 0 or it's maybe greater than 0, then size of the list, then count. If not, we just check if the count is equal to 1. What means is we have just one node in the list. If it is, we delete head and set both head and tail to the null pointer. If not, if we have more than one element, we just have to, like in the insert function, go to the position, so we need the count. We find the position, create temporary node, make a copy of the node, move forward to set connection between the previous node to the node before the temporary. Then we go back by the new created link, set the next pointer to the next node, and we can then delete the temporary node. Of course, we have to decrease the count. Here's a function which simplified the use of the remove position. We just find the iterator where it's pointing, and then we just, if it's pointing on the head, we remove the first. If on the tail of the list, we remove last. If it's somewhere between, we just take that place, do the same like here. So we create the temporary node, make connection between nodes on the both sides of that node we want to delete, and then we can delete that node. Here are just setters and getters to get head of the list, to get tail of the list, or set null pointer. We can also print all list, and here I have to overwrite the operator because I try to print all data from the list instead of getting one by one. I just want to print all data at once, so I have to overwrite that allStream operator, which I find solution on the network in internet. Okay, the database is very simple. Just use the DoublyLinkedList to store all entities. I assume that before I add any element to the list, I straight away check if that element isn't already in the list, but then I have to comment that out to allow to check for the search for duplication, because that function straight away cancel that possibility to have any duplication in the list. So then I just have a search method which just go through list of entities, whole database, and store all results in the results list. You can search by range, last name, whole name. They're very similar methods. Then we have remove by position, where you just call the remove function from the linked list. Then I have searched for duplication, which if we find any, it calls remove duplication, and here it's remove by iterator position. Function to calculate average experience. We just based on level, just compare the level of the item with level passed into. If they the same, you just add to the total the experience points, and if we have something in the total, and we have count to know if we find some matches or not. If we have some matches, just divide total by count, and that's what we return. Same here, just we have to range of the levels, so we need to use add. And here also we have print database function, print results function. That's just for the purpose of the speeding the testing function, which just insert some data on the beginning. Menu function is very easy, very simple. We have just simple menu with enum, where we can choose. We can insert new element, search submenu, which just allows us to specify for what we want to search, and also find the average submenu, which also give us opportunity to say if we want to search by single level or maybe by range. So just very quickly try the function. So first we have already something in the list with a lot of duplications, so maybe print the list. Number of entities is 115, and as you can see, nearly 100 of the entities are Plutolog. They are the same. So we just find and remove all duplicates. Now we have shorter list, just 13 new things. As you can see, we have 3 times Plutolog, but I assume that if we have different capitalization, there are different, like, unique. So that was my assumption for that. And try add something. Insert position for new database. We have 13, so let's say 0, first name, Rad, last name, Chomik, level 1, experience points 1. Okay, print is on the first place. Great. So insert, it's 14 now, so let's say 22. First name, Rat, Chum, level 1, experience 1, print. As you can see, it's on the end. One more time, insert 5, Rat, Chum, 1, 1, print. There it is. Okay, now delete record. Let's say 2. Print. And here on 2 was Johnny Bravo. Johnny Bravo is gone. So number 4 by single level 1.